Right, in this video we're going to talk about equivalent fractions. So for example, I have a rectangle which is divided equally into two parts. Now if I shade one part out of the two parts, so if I shade this part of, for example, one part out of the two parts, like so, so I've shaded one out of the two parts, okay, and if I take another pen, another coloured pen, so a red pen, and if I divide each of these parts equally into two pieces, like so, okay, so we can notice, okay, so we can notice that by doing that, out of the 1, 2, 3, 4 pieces, that two of the pieces have been shaded. So from here we can notice that 1/2 or half is equivalent to 2/4 or 2/4. Okay, likewise, let's try another example. So over here I've got a circle divided equally into 1, 2, 3, 4 parts. And supposing if I shade three of the pieces, so if I shade this piece here, or this part here, as well as this part over here, as well as this part over here, so I've shaded 3 out of the 1, 2, 3, 4 parts, okay, and further to that, supposing if I divide each of these parts equally into two pieces, so if I take a red pen and divide this part here equally into two pieces, as well as this part over here, if I divide that equally into two pieces, and likewise this part over here equally into two pieces, and this final part here, if I divide that equally into two pieces, so in this case I've got 1, 2, 3, 4, 5, 6, 7, 8 parts in total, or 8 pieces in total. So if I revert to the blue pen, so I've got 8 parts in total. So we can notice that out of the 8 parts we have shaded 1, 2, 3, 4, 5, 6. So 6 out of the 8 parts have been shaded. So from this we can say that 3/4 is equivalent to 6/8, or 3/4 is equivalent to 6/8. Right, another example. Let's have a look at this one. So I have a rectangle divided equally into 3 parts, okay. So if I shade one of the parts, for example, so if I shade this part, so I've shaded 1 out of the 3 parts, so 1 out of the 1, 2, 3 parts has been shaded. And if I take a different coloured pen, so go into red, and if I divide each of these parts equally into 2 pieces, so if I take this red coloured pen and draw a line, okay, like so, dividing each of these into 2 pieces. So in this case, how many parts do we have? We have 1, 2, 3, 4, 5, 6 parts in total. We can notice that in this shape, 1, 2 parts has been shaded out of the 6. So from this we can say that 1/3, or a third, is equivalent to 2/6, or 2/6. Right, let's have a look at this example here. 6/8 of this shape is shaded. So let's do this. So I've shaded, so I'm going to shade 1 part, 2 parts, 3 parts, 4 parts, 5 parts, and 6 parts. So 6/8 of this shape is shaded like so. Write down a fraction that is equivalent to this. So we need to write down a fraction which is the same as 6/8. Right, so let me group this so that I have an equal number of parts in each group. So here is one group. And here's another group. So each group, I'm grouping it in a way such that each group has two parts. So here's another group. So one group, two groups. Here's another group of two. And finally, here's another group of two. So I've grouped them so that I have four groups, 1, 2, 3, 4, and each group has two parts. So if I go back to my blue pen, so I have four groups in total, and each group has two parts, but how many groups have been shaded? I have one group, two group, and three groups that's been shaded. So we can notice that from here, 6/8 is equivalent to 3/4. So, or 6/8 is equivalent to 3/4. So how did I get the 3/4? So let me reiterate. So I've grouped it in a way such that each group has an equal number of parts. So in this example, each group has two parts. Okay, so here is the first group. So group 1. Here's the second group, group number 2. Here's the third group, group number 3. Here's the fourth group, group number 4. Okay, so let me be as neat as I can. So group number 4. And out of the 4 groups in total, we can notice that 3 of the groups has been shaded. Okay, let's do the same with this example, number 2. So with number 2, 4 out of 10 beads are shown shaded below. So let me do the shading right now. So here's 1 bead that has been shaded, 2 beads that I've shaded, 3 beads that I've shaded, 4 beads that I've shaded. So 4 out of the 10 beads are shown shaded below. Okay, write down a fraction that is equivalent to this. So at the moment I have 4 out of the 10 beads that are shaded, and we need to write down the equivalent fraction. So let me do the same as above. Let me group them in a way such that I have an equal number of beads in each group. So here's one group. And here's another group. So in this case, I'm making groups of 2. Here's another group of 2. Here's another group of 2. And here's the final group of 2. So if I revert to my blue pen, so I have 1, 2, 3, 4, 5 groups. So 5 groups of 2, and out of the 5 groups, 2 of the groups have been shaded. So we can notice that 4 out of 10 or 4/10 or 4/10 is equivalent to 2/5 or 2/5. Okay, let's have another example. So example number 3, 4/6 beads are shown shaded below. So let's shade those beads. Let's shade the 4 out of the 6. So 1, 2, 3, 4. So 4 out of the 6 beads are shown shaded below. Write down a fraction that is equivalent to this. So I have 4 out of the 6 beads that have been shaded. And let's write down the equivalent fraction. So let's create groups so that we have an equal number of beads in each group. So here's one group of 2. Here's another group of 2. And here's the final group of 2. So I've grouped them in a way such that I have 2 beads in each of the groups. and the number of groups in total that I have are 1, 2 and 3. So I've got 3 groups in total, and we can see that 2 of the groups have the shaded beads. So we can notice that 4/6 or 4/6 is equivalent to 2/3 or 2/3. Okay. Now, what do we notice from each of these equivalent fractions? So let's have an observation of what we notice. So 3/4 we said from the first example here is equivalent to 6/8. Okay, so we can notice that. So if I take a red pen, oh, whoops, let me change the my pen color. So we can notice that 3 to 6, so to get from 3 to 6 we're multiplying by 2, and to get from 4 to 8 we're multiplying by 2 as well. So in other words, in order to get the equivalent fraction, we need to multiply the numerator and the denominator by the same number. So that is the idea in order to get the equivalent fraction. So let me reiterate. So multiply the numerator and the denominator by the same number in order to get the equivalent fraction. So if I take another coloured pen, so a green pen perhaps, so over here, so 3/4, if I multiply the numerator and the denominator by the same number 3, I can get another equivalent fraction to 3/4. 3 times 3 is 9, 4 times 3 is 12. So 3/4 and 9/12 are equivalent. Okay, so you can multiply by a number, but you need to multiply the numerator and the denominator by the same number. So another example, if I have 1/2, and if I wanted to work out an equivalent fraction to 1/2 or half, so remember we multiply the numerator and the denominator by the same number. So for example, if I multiply the numerator and the denominator by 2, 1 times 2 is 2, 2 times 2 is 4, so 1/2 is equivalent to 2/4 or 2/4, and so on and so on. Okay, and likewise, if we go to the second example that we've done, so 4/10 and 2/5, so 2/5, 4/10. So we can notice that over here, so to get from 2 to 4, we multiplied by 2 because 2 times 2 gives us 4, and we also multiplied the denominator 5 by 2. So we can also multiply the denominator 5 by 2, so 5 times 2 gives us 10 in order to get the equivalent fraction of 2/5. Okay, and as with number 3, 2/3, 4/6, so 2/3, 4/6. So to get from 2 to 4, we multiplied by 2. To get from 3 to 6, we multiplied by 2 as well. So we multiply the numerator and the denominator by the same number, which in this case is 2, in order to get the equivalent fraction of 2/3. Okay, as long as you multiply it again, the numerator and the denominator by the same number, you can get the equivalent fraction. Right, example 3, somewhat different. We need to simplify the following fractions. So 4/10. Now the idea here is we need to identify whether the numbers are parts of the times table. So first I'm going to check the 2 times table. Let's see whether 4 and 10 are part of the 2 times table. So 2 times 1 is 2, but 2 times 2 is 4, and we notice that 2 times 5 is 10. So we can cancel the numerator and the denominator by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. And 4 over 10 is the same as 2 over 5. Okay, so in this case 4 and 10 are part of the 2 times table, so you can divide the 4 and the 10 separately by 2 to give us 2 over 5, the equivalent fraction to 4 over 10. And we're done. Now 15 over 21. Let's first see whether 15 and 21 are part of the 2 times table. Now we know that 15 and 21 are not part of the 2 times table. 2 times 7 is 14 and 2 times 10 is 20. Okay, so 15 and 21 are not part of the 2 times table. Let's check the 3 times table though. So we know that 3 times 5 is 15 and 3 times 7 is 21. So if I divide the top and the bottom by 3, so 15 divided by 3 is 5 and 21 divided by 3 is 7. So 15 over 21 is equivalent to 5 over 7. So you can also think of these calculations as, so with example number 1, how many 2's go into 4 and how many 2's go into 10. And likewise for number 2, you can think of it as how many 3's go into 15 or how many 3's go into 21. Okay, but all the same, you need to identify what times table we're going to be using in order to do the cancelling down. Right, 20 over 25. Let's have a go at this one. So 20 and 25, is that part of the 2 times table? Now we know that 2 times 10 is 20, but 2 doesn't go into 25. So both 20 and 25 are not part of the 2 times table. How about the 3 times table? 20 and 25 are not part of the 3 times table. How about the 4 times table? 20 and 25 are not part of the 4 times table. How about the 5 times table? So 5 goes into 20 and 5 goes into 25. So 20 and 25 are part of the 5 times table. So 20 divided by 5 is 4. 25 divided by 5 is 5. So 20 over 25 is the same as 4 over 5. And then we're done. Right, pause the video, have a go at questions 4, 5 and 6. I'll give you a few moments and I'll go through the solution very soon. Right, for number 4, 20 and 24. Let's see whether that's part of, these two are part of the 2 times table. So 2 times 10 is 20, 2 times 12 is 24. So 2 times 10 is 20, or 20 divided by 2 is 10, and 2 times 12 is 24, or 24 divided by 2 is 12. Let's try 2 again. So we know that 10 and 12 are part of the 2 times table because 2 times 5 is 10, 2 times 6 is 12. Or you could say that 10 divided by 2 is 5, 12 divided by 2 is 6. We can't do any further cancellation here, so we can say that 20 over 24 is equivalent to 5 over 6, and we're done. Next one, 16 over 20. Let's start with the 2 times table. Now I know that 16 and 20 are part of the 2 times table because 2 times 8 is 16, 2 times 10 is 20. So 2 goes into 16 8 times, or 16 divided by 2 is 8. 2 goes into 20 10 times, or 20 divided by 2 is 10. Let's see whether 8 and 10 are part of the 2 times table, and they certainly are. 2 times 4 is 8, 2 times 5 is 10, or 8 divided by 2 is 4, 10 divided by 2 is 5. We can't cancel further, so 16 over 20 is equivalent to 4 over 5, and we're done. Now for number 6, 14 over 18. Let's check the 2 time table first. So 14 and 18 are part of the 2 times table. 2 times 7 is 14. 2 times 9 is 18. We can't cancel further. 7 and 9 are not part of the 3 times table, not part of the 4 times table, not part of the 5 times table, not part of the 6, 7, or 8 or 9 times table, so we can't cancel any further, so we leave it as 7 over 9, or 14 over 18 is equivalent to 7/9. Now let's have a look at this set of examples as part of example number 4. So 1 over 3, and we need to complete the equivalent fraction. So we need to complete the equivalent fraction. So these fractions that we're seeing are equivalent to one another. And remember the idea that we've talked about over here. The idea being, in order to get the equivalent fraction, we multiply the numerator and the denominator by the same number. So that is the idea that we need to use with example 4, multiplying the numerator and the denominator by the same number to get its equivalent fraction. So moving to example number 4, we have 1 over 3, and that is equivalent to 2 over this blank that we need to fill in. So to go from 1 to 2, we know that 1 times 2 is 2, and we also need to multiply the denominator by the same number. So 3 times 2, 6. So 1 over 3 is equivalent to 2 over 6, or 2/6. Let me try another one. So we have these equivalent fractions. 1 over 2, that is equivalent to something that we need to fill in on top, over 10. We know that from 2 to 10, 2 times 5 gives us 10, using our 2 times table. So 2 times 5 is 10. So we need to multiply the numerator by 5 as well. So 1 times 5, 5. So 5 should go on the top here. And then we're done. Have a go at examples 3 and 4, and I'll go through the solution soon. Right, with example number 3. From 2 to 4, using the 2 times table, we know that 2 times 2 gives us 4. So we therefore need to multiply the denominator by 2 as well. 3 times 2, 6. And then we're done. So 2 over 3, or 2/3, is equivalent to 4/6. With number 4. 2 over 3, that is equivalent to something over 6, which is equivalent to 8 over something. Let's fill in these blanks. So from 3 to 6, using the 3 times table, 3 times 2 gives us 6. And if I multiply the numerator by 2 as well, 2 times 2 is 4. So 2 over 3 is equivalent to 4/6. Now, from 4 to 8, so we know these two numbers on the top in the numerator. So from 4 to 8, 4 times 2 gives us 8. So if I multiply the denominator by the same number as well, 6 times 2 is 12. And then we're done. So 4/6 is equivalent to 8/12. Have a go at number 5. Take your time, have a go, pause the video, and I'll go through the solution very soon. Right, So 2 over 5, 2/5, and that's equivalent to 4 over something, which is equivalent to something over 30. Let's fill in these blanks. So we know the numerator numbers, the 2 and the 4, but to go from 2 to 4, using the 2 times table, 2 times 2 gives us 4. And if I multiply the denominator 5 by 2 as well, 5 times 2, 10. So 2 over 5, or 2/5, is equivalent to 4/10. Now we know the denominator numbers here and here. So from 10 to 30, using a 10 times table, 10 times 3 is 30. And if I multiply the numerator by the same number 3 as well, 4 times 3 is 12. So 4 over 10 is equivalent to 12 over 30. And then we're done. Right, so that completes the video on equivalent fractions and simplifying fractions. So I hope you enjoyed this video. I hope you liked the video. If you did like and enjoy the video, be sure to subscribe for more content like this, and I hope to see you again. Thank you.